Today we will discuss about the quadratic equation. This is the third part of quadratic equation. We have already done the how to find the roots of the quadratic equation and relation between the quadratic coefficient and roots of the equation. We have already done these topics in first part, and second part we have already discussed about how to construct the quadratic equation when the roots are given to you. In this part, mainly focused, we will discuss only nature of the roots. That means the roots are when the roots are real, imaginary and equal. So now we will discuss about this matter. Okay. So that's why this part I have written here, nature of the roots. So we have already discussed, if the quadratic equation be ax square plus bx plus c equals to 0. This equation where a not equal to 0 and you can consider a, b, c not equal to 0 here. This is the general form of the quadratic equation. So what are the roots of the quadratic equation? We have already done and we have already discussed. So after solving this equation, we will get x equals to minus b plus minus square root of b square minus 4ac by 2 into a. So when we take the plus sign, we will get one root. We will take the negative sign, we will get the another root. So here we will focus only when the roots are real, equal and imaginary. And these roots we can write it is of the form minus b plus minus delta, okay, d by 2a, where d is called discriminant. D is called discriminant. বাংলায় এটাকে বলা হয় নিরূপক। ওকে, what is d? Okay, square root d equals to b square minus 4ac. And you see that if d equals to 0, that means b square minus 4ac equals to 0, you will get x equals to minus b by 2a. So in this case the roots are equal. So I am writing step by step. Okay, so d is called discriminant, বাংলায় এটাকে বলা হয় নিরূপক. So d, which is b square minus 4ac, and this d literally play the role of the nature of the roots. How? Okay, if case 1, if d equals to 0, that means b square minus 4ac equals to 0, then the roots are equal. So what is the condition for equality of two roots? If b square minus 4ac equals to 0. So for the condition of the equality of two roots is b square minus 4ac equals to 0. b square minus 4ac equal to 0, and someone can be written as b square equals to 4ac. So someone ask you the question, what is the condition when the roots are equal? Just you write down b square minus 4ac equals to 0, because you know the coefficient of x square, x and constant, and putting the value you will get the required condition. Okay, so if d equals to 0, then the roots are equal. So what are the roots? Roots be minus b by 2a and minus b by 2a. That means this is a multiple root. Okay, that means x minus 1 whole square. Okay, if you consider x minus 1 whole square, that means x square minus 2x plus 1 equals to 0. And you know that x minus 1 whole square equals to 0, and then roots are x equals to 1. Just I am taking this equation and comparing this condition. What is your b? b a equals to 1, b equals to minus 2, and c equals to 1. So now b square minus 4ac, that's equal to minus 2 whole square minus 4 into 1 into 1. So 4 minus 4, that's equal to also 0. So this is the if and only condition. If d equal to 0 or b square minus 4ac equal to 0, the roots are equal, and either if the roots are equal, then b square minus 4ac equals to 0. Case 2, if d is positive quantity. If d is positive quantity, of course the roots are also real. Okay, so then the roots are equal and real also. And the roots are given by minus b by 2a and minus b by 2a by in the case 1. If d strictly greater than 0, so you see this expression, d is positive quantity. Okay, so we will get two roots, one is the plus sign and another is negative sign. So we will get two distinct roots, and also they are real because the number is real. So if d greater than 0, so the roots are unequal and real. Okay, that means d means b square minus 4ac greater than 0 gives the condition the roots are real and unequal, distinct and real. Okay, b square minus 4ac, this is also if and only condition. If the roots are unequal and real, then b square minus 4ac greater than 0, and if b square minus 4ac strictly greater than 0, then the roots are unequal and real. And we know that real number contain rational number and irrational number. So is there, we can divided this case in two subcases. Okay, one subcase, if the number is perfect square, that means perfect square. What are the numbers of perfect square? You know, 4, 9. That means if you take the square root of the numbers, we will get the irrational phi. So the numbers can be written as an irrational phi number. That number is called perfect square. For example, 1 is the perfect square, 4 is the perfect square, 9 is also perfect square, 16 is also perfect square. That means square root of 4 is 2, square root of 9 is 3. That means you can irrationalize or you can irrational free. This number can be reduced as irrational free number. Okay, so now in this case 2, we will write down a subcase 1. So I have written a Roman 1. Okay, if b square minus 4ac, of course greater than 0, keep it in your mind, and also perfect square, পূর্ণ বর্গ সংখ্যা perfect square, b square minus 4ac greater than 0 and perfect square, then the roots of course are real because greater than 0 means the roots are real. Then roots are distinct and rational. That means মূলদ সংখ্যা. So what is the condition is that when the roots are rational, so if the b square minus 4ac is a perfect square. That means this expression you can write down as a some whole square form. Okay. Subcase 2, if only b square minus 4ac greater than 0 and not perfect square, that means the number be 5, 7, 9, 3, 11, 13, 15, 14, not perfect square, then the roots are distinct as well as irrational. So when the roots are, when b square minus 4ac greater than 0 and not a perfect square, then the roots are distinct and irrational, occur in conjugate pair. We know that if the 2 plus root 3 is a root of the quadratic equation, then of course another root is 2 minus root 3. So occur in irrational conjugate pair. Okay. So we have gotten two cases. For the second case, we have gotten two sub cases. One case is number is perfect square, another is not perfect square. And last of all, we will get if d less than 0. That means b square minus 4ac less than 0. Case 3, if d or b square minus 4ac less than 0, that means you see the, I have written in the expression, I am writing minus b plus minus d by 2a. If d is negative, you see. So the square root of negative numbers, that must be a complex number. I have already introduced in the previous part. Okay. So if d equals to b square minus 4ac less than 0, then the roots are imaginary and occur in conjugate pair. That means if one root is 1 plus I, another is 1 minus I. That are the total information of the nature of the roots. Okay. So specifically, I think it is clear to you. Next, I erase this part. So shortly, I am providing a chart just for memorize this total part. I have taken ax square plus bx plus c equals to 0 equals to the quadratic equation, and the roots are x equals to minus b plus minus square root of b square minus 4ac by 2a, and you can write down minus b plus minus square root of d by 2a, where d b square minus 4ac. I have already said this is called discriminant, and different values of discriminant we get different type of roots. Discriminant. Okay. So total case 1, case 3, case 1, case 2, case 3. I am writing here a chart for memorizing in tricky way. Okay. So if I have taken 3 cases, case 1, d greater than 0, d equals to 0 and d less than 0. So the roots are real and distinct the roots are equal and the roots are equal and roots are minus b by 2a and minus b by 2a. And if d less than 0, the roots are imaginary and occur in conjugate pair. I have already discussed what is conjugate number or conjugate pair in the previous part of the quadratic equation. So in this case we have arised two cases. Subcase 1, if d greater than 0 and perfect square, so the roots are distinct and rational. Distinct and rational. And in this subcase d of course d greater than 0 and not perfect square, so the roots are distinct and irrational and occur in conjugate irrational pair or conjugate pair. That means one number is 2 plus root 3, another is one root is 2 plus root 3, another is 2 minus root 3. Okay, I think you have already copied this part. Okay, so now we will solve some important problems in this context or in this theory. Okay, depend on this theory, depend on this context, we will try to solve some important problems. I have written here 5 problems. Okay, so we will try we will try or we will solve these problems now. How much time? Problem number 1, prove that if the roots of the quadratic equation a square plus b square into x square, if the roots of the quadratic equation a square plus b square into x square minus 2 into ac plus bd into x plus c square plus d square equals to 0, if the roots of the quadratic equation are equal, then you have to show that AD equal to BC. So what is the condition of that when the roots are equal? Of course we know, we knew it already, if b square minus 4ac equals to 0. Okay, so since the roots are equals, then b square minus 4ac, this is your b now, so minus 2 into ac plus bd the whole square, b square minus 4 into ac, this is your a square plus b square, and this is your c, that is 4ac equals to 0. This is your condition. So this is 4 into a square c square plus b square d square plus 2abcd, and after multiplying you will get a square c square, a square d square, b square c square plus b square d square, that's equals to 0. And 4 cancelled, of course, just you write down a square c square plus b square d square plus 2abcd, this 4 is cancelled, minus a square c square minus a square d square minus b square c square minus b square d square, that's equal to 0. And these two are cancelled. Sorry, square d square, b square d square. These two are cancelled. A square c square, a square c square, b square d square, b square d square. So we will get a square d square minus b square c square plus 2abcd equals to 0. We will get a square d square plus b square c square, multiplying throughout by negative sign we will get, so ad whole square minus 2 into ad into bc, just rearranging it, bc whole square equals to 0. Now we will get ad minus bc whole square, and any square quantity is 0 means ad minus bc equals to 0. You will get ad equals to bc, and we will get our required result. Okay, we have gotten already our required result. So we have to show that ad equals to bc, and I have gotten these results also by using b square minus 4ac equals to 0. Okay, I think you have already copied. Okay, so we will discuss the next problem. Okay, I erase this part. Okay, we have already solved the first problem, and now what is our second problem? The second problem is that find the value or values of m for which the roots of the equation is given to you, x square minus 2 into 5 plus 2m into x plus 3 into 7 plus 10m equals to 0. Find the value of m or values of m for which the roots of the equation x square minus 2 into 5 plus 2m into x plus 3 into 7 plus 10m equals to 0 are equal. First question is are equal, roots are equal and roots are reciprocal to each other. Okay, for solving the first equation, so the first condition is that since the roots are equal, so what is the condition? I think you have already answered this question. Since the roots are equal, then b square minus 4ac equals to 0. What is my b? This is b. Minus 2 into 5 plus 2m whole square, this is b square, minus 4 into 1, so this part is 1, into 3 into 7 plus 10m equals to 0. And now 25 plus 20m plus 4m square and 4 into 3 21 plus 30m equals to 0, and both sides 4 are cancelled. We will get 4m square plus 20m plus 25 minus 21 plus minus 30m equals to 0. Am I right? Because 4 cancelled. So 4m square 20m minus 10m plus 4 equals to 0. Okay, so 2m square minus 5m plus 2 equals to 0. After the factorization, we will get 4m minus m plus 2 equals to 0, and you take the common part to m minus 2 minus 1 m minus 2, that's equals to 0. So you will get 2m minus 1 into m minus 2 equals to 0. So what are the roots? What are the values of m? So either 2m minus 1 equals to 0 and m minus 2 or m minus 2 equals to 0, you will get m equals to half and m equals to 2. Either m equals to half or m equals to 2, the roots are equal. So that's why in this question mentioned, find the value or values Okay, so we have gotten two values, m equals to half and m equals to 2. So for m equals to half or m equals to 2, the roots are equal. So we have resolved the first part of the second problem. So next we will discuss the second problem. Second part of the second problem. So problem number 2, if the roots are equal, if the roots are reciprocal to each other. Okay, since the roots are reciprocal to each other, since the roots of the equation equation x square minus 2 into 5 plus 2m plus 3 into 7 plus 10m equals to 0. Since the roots of the equation are reciprocal to each other, then one root is alpha and another is of course 1 by alpha. Reciprocal means one is alpha, because reciprocal, the definition, two quantity are reciprocal to each other if their product is 1. So alpha and 1 by alpha, their product is also 1, so they are reciprocal to each other. Okay, বাংলা এটাকে বলা হয় অনন্য. So we know what is the product of the roots, alpha into 1 by alpha. We have already discussed it in the first part. Alpha into beta equals to c by a. Here alpha equals to alpha and beta equals to 1 by alpha. So the product of the two roots, alpha into 1 by alpha, equals to c by a 3 into 7 plus 10m by 1. So alpha cancel, we will get 1 equals to 21 plus 30m. So m equals to minus 20 by 30. So that's we will get minus 2/3. So when the roots are reciprocal to each other, so the value of m is minus 2/3. Okay, good. Clear? So I erase this part. If the roots of the equation, in the third question, if the roots of the equation a into b minus c into x square plus b into c minus a into x plus c into a minus b equals to 0 are equal, then show that 1 by a plus 1 by c equals to 2 by b. That means the roots are equal. That means b square minus 4ac equals to 0. Since the roots of the equation are equal, then b square minus 4ac, what is my b now? b into c minus a, b into c minus a, b square minus 4ac, this 4 into a into c into b minus c into a minus b, this equals to 0. I have written a into b minus c into c into a minus b. So ac into b minus c into a minus b. So here this equals to b square to a plus c whole square minus 4ac. You can write down also. I am clear? B square into a minus c means a plus c the whole square minus 4ac, and 4AC AB minus B square minus AC plus BC equals to 0. So now B square or B into A plus C whole square minus B square minus B square minus into 4 into AC. Okay, I have previous part I have wrongly written in square form. I erase this part. Okay, so if you multiply B square into A plus C whole square, so that means B into A plus C whole square into B square into 4AC minus 4AC AB minus B square minus AC plus BC equals to 0. So AB plus BC whole square, you can write down just multiplying B with this expression, and if you take 4AC is the common part, you will get minus 4AC is the common part, B square plus AB minus B square minus AC plus BC equals to 0. So B square cancelled, and you will get AB plus BC whole square and AB minus B square minus AC plus BC and 4AC minus 4AC is the common part, B square AB minus B square. Okay, and now we will get 4 plus 4 square C square, this minus 4AC and AC plus minus 4AC into AB plus BC. Am I right? So after this we can write down AB plus BC whole square minus 2 into 2AC, this part I have written, into AB plus BC plus 2 into AC whole square. Just I rearrange it. So in these two lines you remind it. Okay, so the twist here. Okay, so I have taken 4 square C square and multiplying this part AB plus BC, taking club AB and plus BC and multiply with 4AC minus 4AC. So what about this? This is, if you consider A and this is B, so A square minus 2AB plus B square. Okay, so that means A minus B the whole square, AB plus BC minus 2AC whole square, and something square equals to 0, you will get AB plus BC minus 2AC equals to 0. So AB plus BC equals to 2AC. So 1 by C. Okay, I divide all the quantity by ABC So I have gotten 1 by C plus 1 by A equals to 2 by B, and 1 by A plus 1 by C equals to 2 by B. So we have gotten our required result. Okay, 1 by A plus 1 by C equals to 2 by B. Clear? So I erase the question number 3. Next, problem number 4. Problem number 4. If the roots of the equation ax square plus 2bx plus c equals to 0, small a x square plus small 2bx plus small c equals to 0. Let given that alpha comma beta be the roots of the equation ax square plus 2bx plus small c equals to 0. So if the roots of the equation ax square plus 2bx plus c equals to 0 be alpha and beta. So that's why I have written given that alpha comma beta be the roots of the equation ax square plus 2bx plus c equals to 0. So what about alpha plus beta? Alpha plus beta equals to minus b by a. So minus 2b by small a, and the product of the roots alpha dot beta equals to small c by a. And another part also given, the roots of the equation ax square capital Ax square plus capital 2bx plus capital C equals to 0 be alpha plus delta and beta plus delta. Then prove that small b square minus ac by capital B square minus capital AC equals to a by small a by capital A whole square. Okay, and also alpha plus delta and beta plus delta be the roots of the equation ax square plus 2bx plus c equals to 0. So we write down these two equations as equation number 1. Okay, so alpha plus delta sum of the roots plus beta plus delta, that's equals to minus capital 2 into b by capital A. So after simplification we will get alpha plus beta plus 2 delta equals to minus 2b by a, and using the equation 1 we put down the value of alpha plus beta, that is minus 2b by a small a plus 2 delta equals to minus 2b by capital A. From this we will get delta equals to small b by a minus capital B by a, because 2 cancelled both sides. Okay, and from the condition of the product of the roots alpha plus delta and beta plus delta, product of the roots equals to capital C by capital A. So after simplification we will get alpha plus beta into delta plus delta square equals to capital C by A. So now what is the value of alpha into beta? That is small c by a. And what is the alpha plus beta? That is minus 2b by a. What is my delta? I have already gotten delta, the value of delta. Just putting the value of delta in this equation we will get the required relation. B by a by capital B by a and small b by a minus capital B by a whole square delta square equals to capital C by a. So now we simplified it, small c by a minus 2b square by square minus 2 plus 2b capital B by small a into capital A plus small b square by square minus 2b capital B by small a into a plus capital B square by square equals to capital C by a. Okay, so 2bb cancelled these two parts. Okay, so we will get small c by a and minus b square by square. Why? Because I have minus 2b square by square and plus b square by square. So we have gotten minus b square by a square equals to capital C by a minus b square by capital A square. I have taken this part in the right hand side. Okay. So after some calculation, so a square, small square is the LCM. So we will get AC minus b square, and this is capital square is the LCM. So capital AC minus b square. So b square minus AC, I have taken negative is the common part, by capital B square minus capital AC, also taking negative sign, small square by square. Just I have done cross multiplication. So minus minus cancelled, we get b square minus small AC by capital B square minus capital AC equals to small a by capital A whole square. So this is our required result. So proved, I think. So I have done elaborate calculation. Yeah, okay. I think all of you already copied. How much time? How much time? Okay. So problem number 4 I already solved. Okay. So we have gotten already our required result, b square minus AC by capital B square minus capital AC equals to small a by capital A whole square. Next, problem number 5. This is problem number 5. If the roots of the equation x square minus 2px plus q equals to 0 are equal, if the roots of the equation x square minus 2px plus q equals to 0 are equal, then prove that the roots of the equation 1 plus a whole into x square minus 2 into p plus a into x plus q plus a equals to 0, where this condition is very important, where a less than 0 and p not equal to 0 are real and unequal. That means একটা equation, first equation is given to you, the roots are equal, so you will get some conditions. Using that condition, you have to prove that the roots of the second equation be real and unequal. So when the roots are real and equal, if the discriminant is positive quantity, so in this part, using the first result, but this is the equality of condition of the two roots of the first equation, if you take that condition and using in the second equation of that condition, and you have to show the discriminant, that means b square minus 4ac is positive. That we have to show. Okay. So now, given that the roots of the equation, x square minus 2px plus q equal to 0 are equal. That means b square minus 4ac equals to 0. So here b equals to minus 2p minus 4 into 1 into c equals to 0. So I have gotten 4p square equals to minus 4q equals to 0. 4 cancelled. So p square equals to q. That is my condition. I have gotten this condition. So this is the equation number 1. So we have to show, what is our goal? We have to show that using this condition, we have to show that the equation the roots of the equation one plus a into x square minus 2 into p plus a into x plus q plus a equals to 0, show that the roots of the equation greater than 0 and the condition is that a less than 0 and p not equals to 1 are real and equal. So roots are real and unequal. That means we have to show that b square minus 4ac is positive quantity or strictly greater than 0. So now, what is my b square? B means minus 2 into p plus a, b square minus 4ac. I have to calculate it. We have to show this is strictly greater than 0, then the roots are real and unequal. Minus 4 into 1 plus a into q plus a equals to, so no, I have to show this greater than 0. So how to do it? So 4 into a plus p whole square, 4 into q plus a plus aq plus a square. Okay, so we have already proved that q equals to p square, putting the value 4 into a square plus 2ap plus p square, and now put down the value of q, that is p square plus a plus aq square plus a square, because q equals to p square. So now 4 is the common part. I have taken a square plus 2ap plus p square minus p square minus a minus, this is not q square, p square minus ap square minus a square. So 2ap, a square cancelled, p square cancelled. So if you take minus 4a outside, you will get a is the common part, p square minus 2ap plus 1. Okay, so you have taken minus a is the common, so minus a, that is minus plus p square 1 and minus 2ap, so that gives 4a into p minus 1 third whole square. So from the given condition in your question, p is not equal to 1, that means it cannot be 0, and p minus 1 always whole square, p minus 1 whole square always positive quantity, because any square quantity is always positive. And what about a? A is less than 0, minus 4, so minus 4a, this quantity is positive, a is negative, so that negative and this negative after multiplication we will get positive, so the whole result is always positive. Am I right or wrong? You see this expression, according to your question, p is not equal to 1, so that's why p minus 1 not equal to 0 and p minus 1 whole square always positive quantity, and a is also negative and minus sign is outside this expression. A is negative, this negative, so this negative quantity both after multiplication we will get positive quantity, and this positive quantity and multiplication of two positive quantity always we will get positive quantity. That's why this is greater than 0, strictly greater than 0. And what is the condition? Roots are unequal and real. Only condition is that discriminant greater than 0. So I have calculated here discriminant, that is positive, and hence proved. Okay, so okay, thank you.